Calculus! This is AP Calculus Lesson 4-3, Tangent Line Applications. So we are talking today about one example in particular with a sketch, and we're done. It is, again, short notes. So we have a tangent line. It says this line, 4x plus 2y, is tangent. That is our tangent line. And it's going to be tangent to this equation, to this curve, y equals 2x squared plus this unknown k. So you can kind of picture what this is going to look like in your head. 2x squared, that's going to look like a quadratic. It's a parabola, a smiley face parabola, because it's a positive coefficient here. And k is going to move the parabola up and down. It's going to change the vertex. What is k? I mean, obviously we could go into Desmos and just plug both these equations in, k being a slider, and you drag it up and down. But we can solve this with calculus as well. So, and of course, they're going to have you do it with calculus on the test as well. So how do I do this type of problem? So this is the basic setup that you're going to be doing over and over. You look at the tangent, then the curve. Tangent, then the curve. By this time, you should have an answer. It's the same process over and over again. Maybe slightly tweaked in terms of what you plug into where, but you should be able to find it. So with each of these, we're going to be looking at the derivatives and see how that helps us, because we know how to take the derivatives now. So if I take the derivative of this one, and maybe I want to switch things around first. I don't know, what should we do? Should we take the derivative? Should we get it into y form? What should we do for the tangent? You want to get into y form first? Okay, yeah, let's do it. If I do y form, it's going to be y equals what?
2 minus 2x?
2 minus 2x. There it is. I subtracted 4x from both sides. So that's where the negative came from. Divide everything by 2 to get y by itself. All right, once you get into y form, let's go ahead and take the derivative. So that's going to be y prime. Let's just change colors. I'm feeling very colory today. Y prime is equal to what?
Negative 2.
There it is, negative 2. You say it all at once. All right, nice. Well, that'll help us maybe. Let's see if we can find the derivative over here for the curve. We'll take the derivative. Y prime. Ben, you want to do this one for us?
4x plus 4x.
Yeah, just 4x. All right. Does that help us at all? Anyone see a step that we could do?
We can plug in, because we know y prime for the tangent is negative 2, we can plug it into the curve.
Yeah, so that's exactly what we're going to do. This y prime, we know y prime is negative 2. That means this negative 2 is y prime. We're going to plug it in right there. So when I do that, I'm going to switch colors up here. That means I'm going to have a negative 2 being plugged in is going to be equal to our original 4x. When I do that, I'm going to divide both sides by 4, and I get x. What is x?
Negative 1 over 2.
Negative 1 over 2, negative 1/2. Cool. I'm not going to box it because it's not our final answer. Because again, we're trying to find a value of k. Once we find k, that's our final answer. Hopefully this will help us somehow. Okay, tangent. What is the equation of tangent? Maybe we want it in the y equals form. Can someone repeat that for us? What's the tangent equation?
You mean the...
I mean, just when we went to y equals itself.
Yeah, we're going to recopy this one down. It's going to be the most useful. So our tangent equation, just again, writing it down. Y is equal to 2 minus 2x. Okay, and hey, look at this. We have an x. That x is negative 1/2. So I'm going to rewrite this equation. Y is equal to 2 minus 2. Aha, and here, there goes our negative 1/2. That means our y is equal to what?
3.
Y is equal to 3. Because double negative means it's a positive. Positive 1 plus a 2 is 3. Very nice. We're so close. We have our x and y position of where it intersects at the tangent.
Since we know our y and x, we can plug it into the curve. Yeah.
Very nice. I like how you can already see that. Yeah, so let's copy down the curve. And instead of placing a y there, there's our y is equal to 2 times, there's our x squared plus k. We have all of these unknowns ready to go. Our x was negative 1/2, so negative 1 over 2. Our y was 3. Oop, a little bit of lag there. 3. This is 3, went there. I'm just going to do arrows so that you guys can see where things came in right there and there. Maybe I should go like this. That way it doesn't cross over. All right, and then I can solve. So on the right-hand side, go ahead and simplify this a little bit for us.
It'd be 1 over 4.
1 over 4, and it's positive because it's squared. Perfect. 1 over 4 times 2 is?
1 over 2.
Yep, so I now have, I'm just going to copy down that step. 1/2 plus k is equal to 3. And then therefore, k is equal to what? 2.5. And let's box it because that was our final answer. What is k? K is 2.5. What is happening here? What is actually happening with the tangent and the curve picture-wise? Because that's cool, we can do a bunch of math magic, but what does it mean in the context of the problem? So in the context of the problem, we had this parabola 2x squared plus k. That means if we graph that 2x squared plus 2.5, that means I have a vertex down here at 2.5. So 2.5, there's the vertex, and I had a parabola. I don't know what the parabola looks like. We'll use this equation of the tangent. This x and y value that we found, that is the point of the tangency. So this line is tangent at the point negative 1/2, comma 3. So if I graph that point, negative 1/2, comma 3, negative 1/2, comma 3, right here, that's the point where it's tangent. And I know what the slope of that tangent line is, right? Because it told us right here. Negative 2 is the slope of our tangent, which means I have a slope here of negative 2. So if I go down 1, 2, right 1, go left 1, up 1, 2, right about there, and connect that with a line, that is the slope of the tangent. And it does go on forever and ever. So I can go ahead and say it goes on forever and ever that way. That means my curve, my parabola, it should also intersect this point also. So I come up here. I'm going to do my best shot. It's hard because it's so narrow. Like that. Sure, that's my best shot. And there's our parabola. So that means that we had this curve with an unknown value of k, but once we found that value of k, we moved it up 2.5 in order for this point of tangency to make sense. So that's what was happening. All right, so key thing also, if I say that there's a line tangent, that means you're going to be thinking of a derivative immediately. It's going to be hard to remember this later, but let's just go ahead, underline this, f prime. Tangent means at that point, the derivative here, negative 2, is the same thing as the derivative for the curve. This slope of negative 2 is the same for the slope of the curve at that x value. And we found what that x value was.
So wait, though, if the slope of the derivative is negative, then shouldn't it be concave down?
So be careful. That's second derivative, right? Concave is second derivative. The first derivative is equal to the derivative of the tangent.
Well, the derivative of the tangent is the second derivative, right?
This,
At that point.
so you're saying that this is already the first derivative?
Yeah, isn't the tangent already the first derivative?
So this is the line
That
tangent. This isn't f prime. This represents f prime's slope. So this just has the slope. So I guess I should be careful here. This isn't equal to f prime. This has f prime's slope. The slope is embedded into this line that is tangent. Because remember when we have our equation y minus y1 is equal to m times x minus x1. This is the slope, or this is the equation of the tangent. This is the equation of the tangent that it gave us. Our slope, f prime, is embedded into that equation. In order to retrieve that f prime, we had to take the derivative of this thing again to get this back out.
So it basically takes so much work in order to find, in order to
Oh,
do
so
the
That's part of it, yeah.
the graph of f prime is linear.
The graph of f prime,
Parabola.
right.
And then isn't the slope?
The slope should be just the derivative of this, which is 4. The slope should be 4 for the graph of the curve. Because I take the derivative down.
Derivative of y prime.
Right. Oh, it's 4x because, yeah, I don't know why I said it's just 4.
But the y double prime is 4.
Y double prime is 4, yeah.
So it's concave up.
It is concave up. Yep, that makes sense. All right. Are we clear on what's happening in this situation? So we have this tangent line. That tangent line represents the slope. This slope changes depending on what x value we have. The x value that we had was -1/2. Therefore, our slope was -2. We're kind of working backwards in this weird way. We're retrieving what the slope was from the tangent by taking the derivative. Once we find that slope, we set it equal to the slope when we take the derivative over here. The slopes should be exactly equal to each other right here. At this point, x equals -1/2, y equals 3. The slope of that line for the tangent is equal to the slope of that curve. That will always be the case, and that's the general way of solving these problems. The slope of the curve and the slope of that line tangent will be equal to each other at that point of tangency. Okay? Does it feel like I'm saying the same thing over and over again now?
I got it now.
You got it now? Arrow, Ben, or Arrow, Rochelle, how do we feel about this? We're clear on what's going on? All right. That concludes the notes. Go ahead and flip it over to the back. Write something about how the point of tangency represents the same slope for both the curve and the line tangent that we're using to approximate.
So for what we're working on right now, then if the y prime is negative, then now we're making it into concave up. But if it's positive, it's going to be concave down.
That's not necessarily the case. So you're thinking that this tangent represents the derivative. It doesn't represent the derivative. It represents an approximation of the actual curve. So this is just f. This is just f. F prime and f prime are both equal to each other, so f prime represents slope. There's no concavity here. The way to get to concavity is to take the derivative twice, and we don't really care about concavity for this lesson.
Then how do we know how the graph looks? Or like how the...
You know what the graph looks like because it tells you it's 2x squared plus some constant. The constant will make it go up or down, but 2x squared is what the basic graph looks like without affecting the vertical shift.
So if it was
Oh, so
negative...
we do know that 2x squared is concave up just by the equation.
Just by the equation, exactly.
So if it was negative 2x squared, then it would have been concave down?
Yes, exactly. Yeah, good question. Any other questions? All right, that concludes the video.